very much. So I have lots of this side, but nots over here. Lots of, nots of, okay? So what does that mean? That means it mostly goes to the left. So that means this is stronger than this. Okay, they don't usually show that very often, but whenever you see a double arrow, that means the forward reaction is not as strong in terms of acids and bases as the reverse reaction. Okay, lots of stuff to learn, I know. And I'll try to keep reviewing it with you as we go through it. Look, KEQ again from last chapter. This time it's called KA, or as crows. Hey, that way I didn't have to say it. It was so bad. Ka! Okay, so the K of the acid would be equal to, and you know how to fill this stuff in. So what goes on top? Well, put it in there then. Okay, it doesn't fit too good. You'll have to write small. Especially the one on the bottom. You're really going to hate the one on the bottom. I should have given you more room, but it's too late. It works exactly the same way as the K's did last chapter, so don't forget any of that. Or if you didn't learn anything, go back and learn that. And for acetic acid, the K is 1.8 times 10 to the minus 5. I think that's at 25 degrees Celsius. Okay? And there's a table on page 628 for acids and page 647 for bases, so you can look them up. If you were asked on a question and you needed the K. Okay? So don't come back the next day and go, oh, I couldn't solve this because I didn't have the K. Yes, you did. It was on those pages.
That's where you look it up. You just look it up.
Yes.
Are you leaving off the liquid in here? Or why?
Yeah, we left off the water because K is all about concentration. And if you think about it, if you take water and you boil it down, does it get more concentrated? No. So water concentration doesn't change, so we leave it up. And, or you can just say, since it's a liquid, we leave it out, just like we did last chapter. Okay, so a little more information, got to pick it up a little bit because I don't want to take all period. I want to give you a little time to start this, and I want you to look at your tests. Strong acids completely ionize or dissociate in water, completely. Single arrow means strong acid, okay? So there's HCl breaking up for you, and here they are, the big six. You just have to memorize them. I don't even know if I have them memorized. Let's see, HCl, HNO3, H2SO4, HClO4. Is high on there?
Yeah.
I wouldn't have remembered that. HI and HBr and HBr. Those are the strong acids. Notice that 3 of them come from group 17. There's another acid called HF, but it's not a strong acid. Hydrofluoric acid. Isn't that interesting? I wonder why. And you actually know why if you were, and it would be a heck of an AP question. HF is not a strong acid because fluorine is so highly electronegative that it doesn't like to completely break up into ions. So it doesn't, and it's because it's so small. We'll get to that, but that's, well, we don't, it's kind of rare. It would be weak. I don't know, to be honest with you. I don't know what HAT would be, except that it's still hat. That's a good place to eat. If you're in Orange County, it's a good place to eat. You ever eat at the hat?
I stopped. And then he jumped on top of it.
Okay, another time. Okay. So you're going to memorize those 6 for the big quiz tomorrow?
Yes.
Okay.
New quiz.
On the 6 strong acids?
He just told us.
Just memorize the 6.
You have to memorize those 6?
Yeah.
No.
Strong bases. Strong bases, the same doggone thing. NaOH, single arrow, that's why it's a strong base, Na plus OH minus. This is a general thing. Generally, strong bases come from group 1 and from group 2 plus OH. Generally. That's not etched in stone, okay? No. Okay. Mike wants to memorize that for the quiz tomorrow as well.
No,
That's that, okay?